Hello everyone, welcome to the third problem of the Leetcode 150. And today we're going to be solving two sums. So if you're familiar with Leetcode in any capacity, you've definitely heard of two sum. It's a really popular question. So today we're going to solve it and go through the solution step by step. So as we can see here, let's read the problem. So given an array of integers nums and an integer target, return indices of two numbers such that they add up to target. You may assume that each input would have exactly one solution, and you may not use the same element twice. You can return the answer in any order. So let's look at the examples here to get a better understanding of the problem itself. So see here, example 1, input nums. So we have an array of integers here, nums, 2, 7, 11, 15, and the target is 9. So we have to find the indices of the two values in this array that add up to 9. And if you scan over the array real quick, you'll see pretty fast the first two elements of the array, 2 and 7, add up to the target 9. So the output would be the indices of these values. So see output 0, 1, and our output would be an array of the indices of the values. So 0 being the index of 2, 1 being the index of 7. So now we got to think, how can we implement a function to do this? So what most people think of first definitely is the brute force method of doing this. So that would look like basically just going through the array and checking every possible pair of numbers. Obviously that works, but it's pretty inefficient. You would have basically two nested loops, and the time complexity would be all of n squared. For small inputs, that's fine. In the example here, we can see, let me get to the example over here. See the example here, we have just 4 elements, 2, 7, 11, 15. That would be fine, but then if you scale up with the two nested loops, like for example, imagine a list of 1,000 numbers, it gets slow pretty fast. Like that would be pretty bad. So the key question is, how can you find the pair without checking every combination? So that's where we start thinking there's a pretty clever way to do this. So instead of searching the entire list every time, why can't we just remember the numbers we've already seen by storing them in a hash map, or also known as a dictionary in Python? So a hash map is great because you can check if something exists in it in constant time all one time, compared to an array where you just loop through and find if it exists. That takes way longer. So that's why hash map is great. So the idea is here, as we go through the list, for each number we ask, what number do I need to reach the target? So that is just, hold on, let me draw here. That would just be target, which is what we pass, minus n, which is the element we're on in the array. So for example, here we have 2, the target's 9, so 9 minus 2 equals 7. So we are trying to find 7. That's the target we need, or that's the number we need. If that number has appeared before, that means you found the two numbers that add up to the target. So we can do this. Now, how would we use the hash map? Let's ask. So we can start by creating an empty hash map. And obviously a hash map is a key value pair. So we need a key and a value. So then we can store numbers we've already seen as keys. So we can loop through the list. So let's use nums here as an example. So we see nums here. See nums here, right here. So example, the first value, which would be 2. And then we need, so the key would be 2, and then the value can be the index, so which is the index of 2 is 0. And then we can do so on and so forth. 7, 1. So then, yeah, that's how it would be, and then you go up to each. So then, now, we can loop through each number while keeping track of the index using enumerate. So on each loop, I would be the index. We can just keep the index as I, which is right here, 0, 1. And then we can calculate how much more we need to reach the target. So remember, we were saying target minus n. So we can store that in a variable using diff. A diff variable, we just do target minus n. So we can store the difference. And then that will obviously calculate how much more we need to reach the target. So if the target is here 9 and the current number is 2, then we need 7. And if we've seen 7 earlier, that means we've got our pair and we can just return it. So let's go to our here, and then we can start coding the solution. So now we can obviously, let's do this. So let's start now. To sums of nums target. Let's do this now. So now let's initialize an empty hash map, like I said. Hash map equals curly brackets. That signifies an empty dictionary in Python. And then now we start with going through the list. So we can store the index using I variable is called, and then the value itself n. So for I and then in enumerate and then nums, which is our array of integers. And now, as we said here, remember the diff variable here, target minus n, so we can know how much more we need for each value. So now we can store that. Diff equals target minus n, so this will show us how much we need more for every value. So then now we have to check. We can go check in the hash map if this value diff is already in our hash map. If it is, then we found our pair. So if diff, the number diff, is in hash map, in my hash map, and remember that's constant time, so it's pretty good for us, but time complexity wise. So then we can return, and remember we gotta return an array for the indices, array of the indices. So then we return my hash map. So we return the value, remember here, so this is our key. The number itself, the element of the array itself is our key, and the value would be the index. So we have to get the value of our element, which would be the index. So then we just say add diff. That would get us the index. And then just I, simple I here, which would just be the index of the current one, which would be our difference, which is great. So then now, so we've checked the differences here before. If yes, that means the earlier number stored in the hash map and the current number add up to the target. And then, obviously, if it isn't there, then if the value isn't there in the hash map already, then we can just add that to our hash map. So right here, hash map, which would be value n. This will add it to the hash map, or the value at I, or sorry, the value n, which would be the element. equals I, which is the indices, because remember, key value pair. So now this is a pretty efficient solution. So this approach would only look through the list once, only one pass, which is O of n time, which is great for us. And since checking and inserting into the hash map is O of 1, the total time complexity stays linear. So thing is, we are trading a little bit of extra memory. That hash map does take up memory zone, O of n space, but it speeds up the computation way more. So in simple terms, this code works because it remembers what it's seen and uses information instantly instead of rechecking everything. So it is a pretty good example of how hash maps can turn a pretty slow problem. It would originally be slow, as you can see here, the brute force method here, into a pretty fast one-pass solution. So it's great.